Good morning. It's Thursday, October the 3rd. This video is a review of the materials or items, essential highlights of chapters 2, 3, and 4 as a preparation for exam 2, which is on those 3 chapters. You'll have 75 minutes to take the exam once you enter the exam time. There will be 10 multiple choice questions from chapter 2, 10 multiple choice questions from chapter 3, and 20 multiple choice questions from chapter 4. Each of those is worth 2 points, so that's 80 points right there. And then there'll be 3 essay questions. All 3 essay questions are tables or figures that you look at and then interpret. Chapter 2, for example, will be one of the figures from chapter 2 copied into the exam, and it'll be worth 10 points, and the idea is to write a paragraph of interpretation of what you see in that graph. The essay for chapter 3 is a table that obviously would have central tendency sorts of things on it. It's worth 10 points, and you would write a paragraph interpreting what you see in that table. And then chapter 4 is another small table at the end of that segment of the chapter 4 segment of the exam. And again, you would write a paragraph. Interpreting what you see there in that table. Of course, that would be measures of dispersion. So altogether then, that means there's 120 points possible on the exam. An A in this exam is anywhere between 90 and 120. A B is 80 to 89, a C is 70 to 79, and a D is 60 to 69. So the range for making an A is about 30 points, somewhere between 90 and 120 points. So that's sort of the layout of it. A couple of things for chapter 2. Let's got some notes here. Chapter 2, some things to look at. There are, as I can see, maybe 3 segments in that chapter. One having to do with rates, ratios, percentages, and proportions. One having to do with frequency distributions, and one having to do with visual images like bars, histograms, and charts. So beware of those 3 segments. There will be something on the exam from each one. For example, you might have a problem is presented to you on rates, and then you'll have 4 options, A, B, C, and D, on each one of these multiple choice to choose for what you think is the correct answer. You may use a calculator if you like to do those calculations to make to derive your answers. So be sure that you understand the difference between a rate and a ratio. A rate is where you have the numerator is divided by the denominator and multiplied times some value of k, 1,000 or 10,000 or 100,000. And usually a rate has to do with a time interval, a single year or a single month. A ratio, if you'll recall, is where the numerator and the denominator are, I should say the denominator is not the total. In rates, it is the total. The total population, let's say, or the total count, the total class, is in the denominator. And that's true of percentages and proportions. Like if we're figuring the proportion of men in the class, then we'd have the total number of members of the class in the denominator and divide that into the number of men in the class. And that would be the proportion, and then multiply that times 100. And you get a percentage. That's the relationship between percentage and proportion. The ratio is a little bit different because the denominator is not the total. The denominator is another category. For example, if we were thinking of gender and we wanted a ratio of men to women, then we would put men in the numerator and women in the denominator and divide the women into the men, or vice versa. So in rates and proportions and percentages, the numerator is the total number, class, population, whatever it might be, and the denominator is that portion of that total that you're interested in. Infant mortality, let's say, and rate, and like I was saying a minute ago, the percentage of men and proportion of men in the class. In frequency distributions, what that really is about is counting how many frequencies there are. If we're thinking of categorical variables like nominal and ordinal, how many frequency? What's the frequency? What's the count in each one? If, for example, we were going back to male and female, it would be very much like a proportion, but it would be, in fact, a proportion is like a distribution for, and a percentage and a distribution for categorical variables. What percentage are men? What percentage are women? What proportion is men? What proportion is women? What proportion are very happy? What proportion are happy? What proportion are not so happy, in terms of ordinal variables, which are also categorical, but more attitudinal based than are nominal variables. So the frequency distributions for categorical variables of nominal and ordinal are generally percentages and proportions. Now for continuous variables, the frequency distribution is a table, and you'll see that in there. There are a number of instances in Healey in Chapter 2 where he looks at and demonstrates a frequency table. That's where you take an array of data that seems unorganized, and you take the range and subtract the small value from the large value and divide by 10, because generally we want 10 intervals, and then you figure out from there your interval, 3 to 9, 10 to and on down, and then you count out of that array of data how many, or the frequency of numbers that lie between the interval within each interval, and then you can of course do the percentage and all of that. So the frequency distribution for interval ratio variables is a little more complicated to do than the simple proportion and percentage in a categorical variable. So that's frequency distributions. The three principal images from the visualization, the bars, histograms, and charts, are just that. The bar chart, you want to remember, is associated with a categorical variable, so that you would have, say, two vertical bars, one representing men and one representing women, and if there are more women in the class, then the vertical bar for women would be larger or higher than the vertical bar for men, indicating a higher frequency of women. And there's space in between. A bar graph, there are two bars and space in between. A histogram, on the other hand, is a bar chart, but the walls of the bar are contiguous. In other words, they lie right next to one another. They are the same wall, if you will, from one bar to the other. And those are for interval ratio variables, and the connection of common walls of the bars indicates that this is a continuous variable. Whereas in bar charts, male and female, there's no value scale in between them, so it's just a simple space to demonstrate or indicate that it's categorical. But if it's a continuous, and again the walls are contiguous, and the intervals, just like you would see in the frequency table, the frequency table that you might see like this is in like this on the horizontal, and bars indicate those intervals of the frequency table. Just like the the frequency table is, the intervals are, there's no space between them. It goes from, say, 5 to 9, and then 10 to 15, and then 16 to whatever. It's continuous, just like what the bar chart would look like, that we would call a histogram for continuous variables. The essay, and then you have the charts, which you have the lines. You might have some value on the axis, and then a y-axis, then an x-axis of, say, years, and it shows a line that shows something that moves from year to year across that chart. know what those charts are, how to interpret them. The essay will be a chart that has been taken from Chapter 2 and put in the exam, and then you will write a one-page paragraph interpretation. I don't mean one page, but one paragraph interpretation of what that chart says, looking at the similarities and contrast, because these charts will have two lines on them of one sort or another. Okay, that's Chapter 2. Chapter 3 is about central tendency. This is where we take the distribution and collapse it, shall we say, to the center, find the pivot, much like a teeter-totter. Where is the center of that distribution? And so we're focusing on the central tendency as opposed to the breadth of the distribution. And there are a number of techniques we use. Mode is one, median, and mean. And all three of those apply to interval ratio. If you've got a distribution that has a value that is two or more of those, like if you've got a distribution that's got 2 3s, then the mode would be a 3. Would be 3. And then you have the median and the mean, and let's set that aside for a minute. The mode applies to both categorical and interval ratio. The mode is the central tendency that you would use most often with categorical variables, whether it's an attitudinal variable or a nominal variable. And the mode would be simply which category has the highest number. Doesn't have to be over 50%. It's just the category that has the highest number. And of course, if you've got two categories, one being males and female are more than males, and of course they would be more than 50% and also be the mode. But if you had an attitudinal variable, let's say a very happy, happy, and not so happy, and there was 30 in one and 30 in another and 40 in another of those three, neither one of those three would be the majority, but the one that had 40 would be the mode. Now for the mean and the median, there's some things to keep in mind here. Not only how to calculate them, so be mindful of the formulas in Chapter 3 on how to calculate mode, the median and the mean. The sum of xi minus x bar, sum of xi over n for the mean, and then the two ways of doing the median if the distribution is odd, and then if the distribution is even. There are two different ways, one for each, the odd distribution and one for the even distribution formulas, and you'll see those in that chapter in Healey. Be aware of how to calculate out the median. Be sure you understand the difference between the median and the mean. In a distribution, the median is always the geographic center of the distribution. It's the centermost value. The mean can be pulled to the left or right. If there are some high values to the right, it'll be pulled to the right. So the mean will be higher in value than the median. If there are some very low values, the mean will be pulled to the left-hand side of the distribution, and it will the mean will be pulled in the direction of the low values. Now, we think of skew, so if the mean is pulled to the right of the median, that's a positive skew. If it's pulled to the left, that's a negative skew. And the reason we say that is that if we were to subtract, and you want to be aware of this, if we were to subtract the mean in the center of the distribution from any of the values to the right of the mean, which are all values larger than the mean, and the distribution on the far right-hand tail is the highest value, on the far left-hand tail is the lowest value. So if the mean is subtracted from any of the values to the right of the mean, that would be a plus, because all of those x's out there to the right are larger. If the mean is subtracted from any of the values to the left of the mean, then those values are smaller, so that subtraction would end up with negative values. So when we look at the distribution, the positive side is to the right of the mean and the negative side is to the left of the mean. And if you remember, we're beginning to talk about shapes of the distribution. Always remember when we look at that bell curve that behind that bell curve are bar charts. Small frequency bar charts at either end, and getting larger bar charts as we get to the center, and then the largest bar charts right in the center. Distributions tend to heap around the middle, and we'll talk more about that in chapter 6 and 7, but they tend to heap around the middle, and then if you draw lines from the top of each of those bars, you'll get kind of a bell-shaped curve. So if the mean is to the right, that bell-shaped curve gets skewed to the right with a longer tail, and if there is some low values to the left, then that tail of that curve will be skewed to the left and be negative with a longer than what we might expect tail to the left. So be mindful of skew and the relationship between the median and the mean. And of course, if the mean and the median are approximately the same value, then they're right in the center of the distribution, both of them. And when we think of the visualization of that curve, then the curve is normal and symmetrical. 50% of the distribution to the right of the mean and median, and 50% of the distribution to the left of the mean and median. So keep those kinds of relationships in mind. There will be a percentile on the exam. So if you want to know, for example, you array your distribution from the lowest value on the left to the highest value on the right in a numerical sequence like that. And then if you wanted to know what the 70th percentile is, you take the number that is in the distribution, say it's 20, and 20 values in the distribution, and you multiply 0.7 times 20, and that would give you 14. And then at that point, that's not the percentile. Then what you would do is you'd count from the lowest value, 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14. And when you got to the 14th position in the distribution, that would be the 70th percentile. The percentile is like the median. When you do the formula, what you find is the position in the distribution, but then you have to recognize that what is the x, or the value that's in that position, that is derived from the formulas for the median and for the percentile. So keep that in mind. You can't just simply report 14 in the illustration I just gave. You've got to see what is the x that's in that 14th position. Okay, so that's the percentile. Be mindful that if we were to do a sum of xi minus x bar, that would equal 0. And there again, if we subtract the mean from the values on the right, positive, and subtract the means from the values on the left in a normal distribution, and sum those up, they'd be 0. All the negatives and the positives would end up to a sum of a 0. So that's why in chapter 4, and we begin talking about at the end of chapter 3, why we square that in order to get the variance. Okay, chapter 4. This is about dispersion, whereas chapter 3 was about sort of collapsing to the center of the distribution to find one value that represented the center of the distribution. Now what we're doing with chapter 4 is we're ranging out across the distribution to capture all the variation that there is. That between the low and the highest, between the mean and any value to the left or the right, between any value to the right and a value to the left, all of the variation and differences that there are, all the dispersion that there is in that distribution is what we try and capture with the techniques, in chapter 4. There are a couple that I want you to keep in mind before we get to standard deviation. That's the interquartile range. The interquartile range, if we think of the distribution in 4 quartiles, the top 25%, the bottom 25%, and the two 25% in between, or the 50% in sum, if we look at the middle 50% of the distribution, then by doing that we're excluding these weird outliers, shall we say, on either the left or right. Things that pull the tail to the right or pull the tail to the left. When we do an interquartile range, we're removing those influences from the interquartile range, and then we can compare the interquartile range of one distribution to the interquartile range to another, and perhaps get a little better view of the comparison of those interquartile ranges, without regard to the outliers that are pulling those distributions one way or the other. Now, it's a good practice, a good thing to do. It's a common statistic. But of course, the thing that happens here is we lose all the information in the bottom 25% and the top 25% because they're excluded. So a lot of the variation that's in the distribution, as much as 50%, 25 on the one side and 25 on the other, we lose as much as 50% of the distribution. So it's not a completely satisfactory way of doing that. The other one is the range. The range is the subtraction of the low value from the high value. And that tells us something. And if there was another distribution where we did the low value from the high value and we got a larger range than the one that was former, then we'd say, well, the one with the larger range has more distribution and dispersion. But the issue with that is we only are working with the two values in the extremes of the distribution, and we're completely lost about what's going on in between those values. So it's not a very satisfactory measure at all, even less so than the interquartile range. The one that's the most important to us in this chapter is the standard deviation. And we begin with the variance, which is the sum of xi minus x bar squared. Whereas in chapter 3, if we had just done that without the squaring, that would have been a 0. But when we square it, turns all the negative values to positive, and so we can sum all that up and get a value, and then divide it by n and get a variance. And then what we do is we take the square root of the variance to derive the standard deviation. And the standard deviation is really the value of utmost consequence for us in chapter 4. It is like the mean or the median in central tendency as the measure of central tendency in a continuous variable. In measures of dispersion, standard deviation is the single most important measure for measuring dispersion. Now, one of the things when we think about the standard deviation is its index value. And this is how we would read that. If you're looking at two distributions and one has a larger standard deviation than the other, then we would say that the one with the larger standard deviation has more dispersion. It has more diversity, has more variation in it than one with the smaller standard deviation. The image of these, the normal curve images, are at the beginning of both those chapters actually. One, I think, in chapter 4 on IQ and the one in chapter 3 on ambulance response. The greater the dispersion, the rounder the bell is, the broader the bell curve is. The smaller the standard deviation, the narrower the bell, the more heaped it is. So the broader the bell represents a broad distribution, a larger standard distribution, and then one that is narrower standard distribution or standard deviation would have a narrower bell. So the standard deviation is very important as an index. If you just see that number compared to it, anytime you just see one number, you really know. But if you've got two standard deviations and one is larger than the other, then you know that one's got a broader curve, a broader distribution, and all of that real quickly with that one value. And that's the index power of the standard deviation. So be mindful of that. And remember, there's 10 chapter 2, 10 chapter 3, and 20 in chapter 4. So if you think about it, I want you to think carefully and more about chapter 4. I have the three, I think at this point, chapter 4 has the greater significance in our statistical development. Okay, so that's a review for the exam that will be posted sometime in the next, this is Thursday morning, about 8 o'clock. Sometime in the next 24 hours I will post that exam and email you and let you know that it's posted. And then again, you'll have 75 minutes to take it. Okay, so next week is chapter 5. Homework is due. Later today I'm going to do a video on chapter 5, so you'll have a couple of videos posted today. And then on Tuesday of next week, beginning next week, we're into chapters 6 and 7. So once you finish the exam and you get your chapter 5 homework, begin to focus on chapters 6 and 7. All right. Thanks a lot. Talk to you later. Y'all be careful out there.